Today we are going to talk about the inverse of a function. Let's see what exactly is a function. You can look at a function like a machine. If you represent a function with this figure, you give some input to the function, which usually is your x value. The function does some operation on your input, which is x, and is going to output, what we call y. So the function is like a machine. It gets some input, something like x, and it does some operation and gives you the output, which is y. An example of a function in real life is like a washer. You put the dirty clothes inside, it washes the clothes. This is the operation, and it outputs, and the output is the clean clothes. The function does the same thing. For instance, when you have something like y is equal to x plus 1, if the input is x is equal to 1, it's going to add 1 to the input, which is 1 plus 1, and it's going to output the value y is equal to 2. Now, the inverse function does exactly the same thing, but in reverse order. The inverse function gets an output, does the reverse operations on it, and is going to return the original input. So the inverse function is exactly the same operation as a function, but in reverse order. It gets the output and returns the input. Now, how do we specify the inverse of a function in math? If the function is f, then we specify the inverse as f minus 1. Now, one thing you have to remember, that f minus 1 is not the same as the exponents, meaning f minus 1 is not equal to 1 over f. This is the notation we use for the inverse function, f minus 1. Now, the main property of the inverse function and the function is the following. If you have a function f, if f of, let's say, the input a is equal to b, then the inverse function, which is f minus 1, if we give the b value, which is the output, to the inverse function, we get a. So remember, if a is the input to the function and we get b, the inverse of the function f, which is f minus 1, if we give the output b to that function, we get a. So that's the topic of this lesson. Now we are going to do some examples here. In the first example, we have a table of value with a function of x at different points. For instance, when x is negative 5, y is 0. When x is negative 4, y is 2, negative 3 is 5, negative 2 is 6, and 0 and 7. First, we have to find f minus 1. Based on the definition of the inverse function, the inverse function becomes 0 and negative 5. Remember, if f of a is equal to b, f of minus 1 of b is equal to a. So f of minus 1 of 2 gives you negative 4, 5 gives you negative 3, 6 gives you 2, and 7 gives you 0. You just switch x and y. This is going to be your inverse function. Now we are supposed to graph f of x and its inverse. So if this is my x and y coordinate system. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. F of x, if x is negative 5, y is 0, this point. If it's negative 4, it's 2, so it's going to be somewhere around here. If it's negative 3, is 5, so it's going to be somewhere around here. And if it's negative 2, is 6, so it's going to be somewhere around here. And if it's 0, it's 7, so it's going to be somewhere around here. Now f of minus 1 of x, from this table we can see that if x is 0, y is negative 5, somewhere around here. If it is 2, x is 2, y is negative 4, so it's going to be somewhere around here. If it's 5, if x is 5, y is negative 3, so 2, 4, 5, and it's negative 3, so it's going to be somewhere around here. If it's negative 2, if it's 6, then f of negative 1 of x is 2. 6 is negative 2, which is here. And if x is 7, y is 0. So you get something like this. But if you have noticed, the graph of f of x, which is this one, and graph of f of minus 1x, which is the inverse, it is a reflection on the line y equal to x. So this tells us that if we don't have the equation or the function f of x, and we are supposed to find the inverse of the graph, you just reflected about the line y equal x. Meaning that if I have a graph like this one for f of x, I'm going to find the inverse of this function about y equal x. This means that this point is going to be reflected here. This point is going to be reflected here. This point is going to be reflected here, and so forth. And then we can connect it together. So we can find the inverse function. In fact, the graph of the inverse function. Now we have to find the domain and the range of f of x. You can see that the domain of f of x is negative 5, negative 4, negative 3, negative 2, and 0. And the range is 0, 2, 5, 6, and 7. Now for the inverse function, the domain and range, they switch. So the domain of f of minus 1 is going to be the range of f of x, which is going to be 0, 2, 5, 6, 7, which is easily, you can see from here, these are the x values of the inverse function, and the range is going to be negative 5, negative 4, negative 3, negative 2, and 0, which is the y coordinate of the inverse function. Now, the next question I can ask is that, is the f of x a function? You can see that it passes the line, vertical line test. Yes, it is. Is the inverse a function? And again, the same thing. It passes the vertical line test, or you can say that the x values are unique. There is no repetition of x values here. In the next example, we have the function f of x is equal to 2x minus 3. We're supposed to find the inverse of f of x, graph f of x as it and its inverse, and decide either inverse of f of x is a function. When you're dealing with a function like f of x is equal to 2x minus 3 in this format, to find the inverse of the function, the steps is that we are going to solve for x, or another way of putting it, when we isolate x, at the end we are going to replace x with y. What you get is f of minus 1. What exactly it means is the following. F of x is 2x minus 3. I'm going to write this one as y. So I'm going to say y is equal to 2x minus 3. Now I'm going to isolate this one for x. So I'm going to move negative 3 to the right. I get 2x is equal to y plus 3. Now I'm going to divide by 2. I'm going to get x is y plus 3 over 2. Now I'm going to replace x with f minus 1 and y with x. This is going to be the inverse function. Now to graph it, the function f of x is this one, so we are going to, first of all, it's a line, so I'm going to find the x and y intercept. X-intercept is when y is equal to 0. So when y is equal to 0, I get 2x minus 3 is equal to 0. So I get 2x is equal to 3. So x is 3 over 2, which is 1.5. So this is my x-intercept. So if this is 1, this is 2, this is my x-intercept. Y-intercept, obviously it's apparent, is negative 3, or you can say y-intercept x is 0. So 2 times 0 is 0 minus 3, so it's minus 3, 1, 2, 3. This is minus 3, so this is going to be my function f. Now to plot f of minus 1, I do exactly the same thing. To find the x-intercept, I'm going to set x equal to 0. If x is 0, then f minus 1 is 3 over 2, which is 1.5. So this means that 1.5 is here. Now we find the x-intercept is when y is equal to 0. So this becomes x plus 3 over 2 is equal to 0. So x is negative 3. So 1, 2, 3, this one. And when we connect them together, we get a line like this one. This is f minus 1. Now if you look at these two and the line y equal to x, you can see that f and f minus 1 are reflection of each other on the line y equal to x. Now, is f and f minus 1 functions? The answer is right, is true, because if I drop vertical lines, you can see that for the function f, the vertical line crosses the line only at one point, and the same for inverse function. It crosses the inverse function only at one point. In the next example, we have the function f of x is 2x squared plus 16x plus 29. First, we have to find the inverse function. There are two ways we can find the inverse function. One method is, since we are dealing with quadratic and we need to find or isolate x, we can either use completing squares or using quadratic formula. Let's try both of them and see what will happen. If we use completing squares, we know the rule is that the leading coefficient, meaning a, has to be 1, so I'm going to factor a, which is 2, from the first two terms. So I'm going to get x squared plus 8x plus 29. Then I'm going to divide the coefficient b by 2, so I get 4, square it 16, add and subtract 16 from the bracket. So I'm get x squared plus 8x plus 16 minus 16 plus 29. Now if you look at these three terms, if I put bracket beside them, this is a perfect square, so I can write this one as 2x plus 4 squared minus 16 plus 29. Now I'm going to distribute 2 inside. I get 2 times x plus 4 squared minus 32 plus 29, which is 2 times x plus 4 squared minus 3. Now I replace f of x with y because it's easier to write, so I'm going to write this is equal to y. Now I'm going to isolate x by moving this guy to the right, so I get 2 times x plus 4 squared is y plus 3. Now I'm going to divide by 2. I get x plus 4 squared is y plus 3 over 2. Now the inverse or the opposite operation to square is square root, so I take the square root of both sides, but when you take the square root of y plus 3 over 2, you get plus or minus. So you end up with x plus 4 is equal to plus or minus square root of y plus 3 over 2, or x is equal to negative 4 plus or minus square root of y plus 3 over 2, or the last step is to replace x with f minus 1 and y with x. So I get the inverse function is equal to minus 4 plus or minus x plus 3 over 2. So that's my inverse function. Just by looking at this, you can see that the inverse is not a function, because for every value of x, I'm going to get 2 values because it's plus or minus here. So it's not going to pass the vertical line test. Now, this is one method. There is also another method, which is quadratic formula. Let's try to use quadratic formula and see if we can get to the same inverse function. To use the quadratic formula now, I'm going to replace f of x with y, and then I'm going to try to solve this guy using quadratic formula. So I'm going to write this one as equal to y. I'm going to move y to the left, so I get 2x squared plus 16x plus 29 minus y is equal to 0. Now, to use the quadratic formula, I know that the 2 roots x1 and 2 is minus b, which is minus 16, plus or minus b squared, which is 16 squared, minus 4ac, minus 4 times 2 times 29 minus y over 2a, which is 4, which is equal to negative 16 plus or minus. Now, 16 squared is 256 minus 4 times 2 is 8. Now I distribute this one by multiplying by each term in the bracket, so 8 times 29 is going to give me 232, and negative 8 times negative y gives me plus 8y divided by 4, which is going to give me negative 16 plus or minus square root of 256 minus 232 gives me 24, plus 8y over 4. So far, this result is not the same, doesn't look the same as the previous one. So what I'm going to do, I'm going to separate the fraction. So I'm going to write this guy as negative 16 over 4 plus or minus, and I'm going to bring this one under the square root. So I'm going to get 24 plus 8y divided by 4 squared is 16, so 16. Now negative 16 over 4 is negative 4 plus or minus. Now 24, 8 and 16, they have 8 common between them, so 24 divided by 8 gives me 3 plus 8 divided by 8 gives me 1 divided by 16 divided by 8 gives me 2. Now, this is going to be my x isolated, so I'm going to say f minus 1 based on this is going to be minus 4 plus or minus square root of x plus 3 divided by 2, which is exactly what we got in the previous technique too. So it doesn't matter if you use the completing square or using the quadratic formula, you are going to get the same thing. But remember, we could use either one of these methods because we are dealing with a quadratic equation. And also the same way, the inverse function is not a function, it's a relation, because for every x I get two values because of the plus or minus. Now the only thing which is left is to plot the two graphs. Just remember that when we changed the function f of x into vertex form, we found y equal f of x, the same thing, equal to 2 times x plus 4 squared minus 3. Just by looking, we know that the vertex is negative 4 and negative 3. Let's find another point here, the y-intercept. We know that the y-intercept is when x is equal to 0, so y-intercept is 2 times 0 plus 4 squared minus 3, which is going to be 29. So the point is 0 and 29. So if we want to plot this graph, we are going to have point negative 4 and negative 3, so 1, 2, 3, 4, 1, 2, 3. This point is going to be our vertex. Since the leading coefficient 2 is positive, parabola opens upward. We also know that the points 0 and 29 is going to be our y-intercept. Let's assume 29 is somewhere around here. Now to find the next point, we know that this is axis of symmetry, the line which goes through the vertex. So what we can say about this point 0 and 29, it is going to be on the left of axis of symmetry, the same distance away. So if the distance from this point to the axis of symmetry, which is here, the other point is going to be to the left the same amount. So this point is going to be, if axis of symmetry, the x value is negative 4, so this guy is going to be negative 8 and 29. So our graph is going to look something like this. Now we are going to plot the graph of the inverse. Again, inverse, we found that y or f minus 1 is negative 4 plus or minus square root of x plus 3 over 2. Since x plus 3 over 2 has to be positive or greater than or 0, then we know that x plus 3 over 2 has to be greater than 0. From here I get x plus 3. If I multiply both sides by 2, I get x plus 3 has to be greater than or equal to 0, so x has to be greater than or equal to negative 3. So let's find a couple of points here. If x is negative 3, x plus 3 is 0, 0 over 2 is 0, so we get negative plus a negative 4 plus or minus square root of 0, which is 0. So the first point is if x is negative 3, y is negative 4. So this is our vertex now. The next point, let's say x is negative 2, we get negative 4. Now, if x is negative 2 plus 3 is 1, so we get negative 4 plus or minus square root of 1 over 2, which is either negative 4.5 if we go with addition, or negative 3.5 if we go with subtraction. So if x is negative 3, which is this point here, y is negative 4.5, which is going to be, if this is 5, 6, 7, 8, so it's going to be somewhere around here. And if x is negative 2, y is negative 3.5, which is going to be somewhere around here. So these 2 points. The next point we are going to pick is negative 1, so you get negative 4 plus or minus. Negative 1 plus 3 is 2 divided by 2 is 1, so we get square root of 1. Now, if we go with positive, we get negative 4 plus 1 is negative 3. If we go with negative, we get negative 5. So if x is negative 1, y is negative 3, which is going to be a point close to here, and negative 5, which is a point close to here. Now we can see how the graph looks like. The graph is going to be something like this. Now, if you look at the line y equal x, the one that I said, if you are given the graph, you can reflect it upon the line y equal x and get the inverse of the function. You can see that the reflection of this graph on this line is going to produce the same graph that we drew here. Now, if we want to know what is the domain and range here, for the main function, which is this function, you can see that the domain is x in R, and there is no other restriction on x. X can go from negative infinity to positive infinity. But the range is y in R, but y has to be greater than or equal this minimum value. And the minimum value, if you look at the vertex, is negative 3. So we can say y greater than or equal to negative 3. Now, if we look at the inverse function, which is this one, you can see that the domain now is x in R, but x is greater than or equal to this point here. And this point, we found that it's negative 3. So x has to be greater than or equal to negative 3. But the range now, because these two branches, they go to infinity plus or minus, so we can say that y is in R. And if you compare the domain and range of the original function, which is this one, and the inverse function, you can see that the domain and range are flipped. For the original one, the domain was x in R, but for the inverse one, the range is y in R. For the original one, the range was y in R and y greater than or equal to 3, but for the inverse one, the domain now is x in R and x greater than or equal to negative 3. And this fact is true for any type of function. In the next example, we do have the relationship between the speed of the car and its stopping distance, which is given by the function d is equal to 0.006 v squared. D is the stopping distance and v is the speed. The graph of d versus speed is given here. And the graph of the inverse function is also given here. The question is the first one, state the domain and range of the function d. When you look at this function here, you can see that your speed values, or the x values, are going to be from 0 upward. So we can say that the domain is v in R, and v has to be greater than or equal to 0. The range values are the y values, which are the stopping distance, and you can see from the graph that they can start from 0 and they can go upward to infinity. So we can say that the range values are s, which are in real numbers, and s has to be greater than or equal to 0. The second part of the question says determine an equation for the inverse and state its domain and range. Here we have to isolate v, so I'm going to divide both sides by 0.06. So I'm going to get v squared is d over 0.006. Now I'm going to get the square root of both sides, so I'm going to get v is equal to square root of d divided by 0.006. Now you may be tempted to say plus or minus, but since the domain of the function d previously we found was d, the domain, not the variable, the domain was d in R, and d has to be greater than or equal to 0, and range was v in R, and v has to be greater than or equal to 0. Here, the only allowable range of value is positive values for v. So we can say that v is equal to only positive root of square root of d over 0.06. Now to find the domain and range, you can easily see either from the graph that we had before, or from this equation we can say that d over 0.006 has to be greater than or equal to 0 because it's under square root. From here, if I multiply both sides by 0.006, I get d has to be greater than or equal to 0. So the domain is d in R, and d has to be greater than or equal to 0. And your range is going to be the positive root of d over 0.006, and it can be 0 the minimum, and it can go to infinity. So we can say that the range is equal to v in R, and v has to be greater than or equal to 0.